Exercise 216 is trying to train you to see lone pairs on nitrogens. So it says draw all the lone pairs on each of the nitrogen atoms in the following structures. First review table 2-3, which I've included here, and then come back to these problems. Try to identify all the lone pairs without having to count, and then count to see if you are correct. So they have a little shortcuts here if you want to memorize them. If a nitrogen has a negative charge, it'll have 2 bonds and 2 lone pairs. If a nitrogen has no charge, it'll have 3 bonds and 1 lone pair. And if a nitrogen has a positive charge, it'll have 4 bonds and 0 lone pairs. So you are welcome to memorize that and apply it to these problems. You could also use a similar procedure as we used in the exercise for identifying lone pairs on oxygens. And for that, you look to see how many electrons are around the nitrogen, and you add lone pairs until you get a total number of electrons of 8 around the nitrogen. Nitrogen is in group 5A, so 1, 2, 3, 4, 5 would be the Lewis dot structure for that, and then it'll form bonds normally until each of these other electrons are paired up. Notice, once all the electrons are paired, the nitrogen's stable, and so normally a nitrogen will have 8 electrons around it. So we want to fill the electrons around these nitrogens until they have 8 electrons, and we'll do that by adding lone pairs. So this nitrogen here in A already has 1, 2, 3 bonds. Now every bond is made up of 2 electrons. So that means this nitrogen already has 2, 4, 6 electrons around it. To get 8, we would just add 7, 8, 1 lone pair. Remember, a pair is 2 of something, so this is just 1 pair, 1 lone pair. For this next nitrogen, the nitrogen has 2, 4, 6 electrons around it, so it only needs 7, 8, 1 lone pair. In this one, the nitrogen has 2, 4, 6 electrons around it, so you'd only need 7, 8, 1 lone pair. In D, this nitrogen has 2, 4, 6, 8 electrons around it already, so you would have no lone pairs. That is the answer as drawn. In E, this nitrogen has 2, 4 electrons around it, so you would add 5, 6, 7, 8, 2 lone pairs. This nitrogen has 2, 4, 6 electrons around it, so you would add 7, 8, just 1 lone pair. In G, the nitrogen has 2, 4, 6, 8 electrons around it, and so you wouldn't add any lone pairs. That nitrogen is correct as written. In H, first, the nitrogen on the left has 2, 4, 6, 8 electrons around it, and so you wouldn't add any lone pairs. It already has 8 electrons. The second nitrogen, and this may be a little trickier to see, let me draw that expanded a little bit. So you'd have, here's your structure, you've got the nitrogen there, hydrogen, this nitrogen has a positive charge, then you have this nitrogen. Now notice this NH2. What that means is that this nitrogen is bonded to 2 hydrogens. So if we look at this nitrogen, you'll notice that around it are already 2, 4, 6 electrons. So to give it 8, you would just have 7, 8, 1 lone pair. So 7, 8, 1 lone pair on that nitrogen. Oops. And so that's how you would go about identifying the lone pairs in the nitrogens, which will be important because those lone pairs soon will move, whether within a molecule or between molecules. So being able to see where they start on a molecule will be crucial.